umaga, guys, tanghali, hapon. So, nandito kami para mag-report na aming kagrupo. So, ang topic for today is called wind turbine. So, let's go. Mas rapid yung wind turbine. Ano ba sa tingin yung una pumapasok sa inyo? Isipan nyo. Siyempre, wind, no? So, tama kayo dyan. Correct, let's go. So, ito yung tsura ng wind turbine. So, pag pinlay natin to, makikita natin umiikot, diba, stick. Pero kasi ginagawa yan, kaya umiikot. So, mamaya natin tatakal. At ang aming mga grupo. So, ito yung tsura niya, malapitan. At ito yung tsura ng loob. So, first, punta tayo sa wind turbine parts and operating principles. So, wind turbine operating principle. Wind turbine is a type of a renewable energy that harnesses the power of wind to produce electricity. The basic idea is that wind turbines uses rotor, which attach blades to collect wind's potential and kinetic energy. Wind turns the blade, which spins a shaft that is connected to generator, which results in the generation of electricity. A large number of wind turbine is usually called wind farm. So, etong wind turbine, siya pala yung gumagawa ng energy. Or siya yung gumagawa ng renewable energy depends na para gumawa ng electricity. Isa siya sa mga pwede mag-produce ng energy. So, basically, etong turbine, sila yung parang wind-based renewable energy. So, pag maraming wind turbines, or sabihin natin, di lang siya bilang, at tawag sa kanya ngayon ay wind farm, di na siya wind turbine. So, next, pupunta tayo sa parts. So, nakikita nyo lang sa parts, dito yung rotor, pitch, low speed shaft, gearbox, generator, controller, anemometer, wind vane, nacelle, high speed shaft, yaw drive, yaw motor, tower. So, tatalakayin natin lahat yan later. So, wind turbine. Parts and function. Blade. So, the blade is the part that rotates due to the force it catches from the wind. It is connected to the low speed shaft by the hub. The low speed shaft is connected to the gearbox and the gearbox to the generator. Once the blade rotates, it causes the rotation of generation, thereby generating electricity. Most wind turbine consists of 3 blades for maximum efficiency. So, makikita natin sa diagram o sa picture, makikita natin yung hub. Yung hub, naka-attach dun yung blades. Nasusunod sa hub, nandun na yung low speed shaft. At nakapakita sa low speed shaft at brake ay ang gearbox. So yan, nakikita natin sa diagram kung paano gumagana or paano yung pagkakasunod-sunod ng components para mag-produce ng electricity or paano pagkakagawa ng wind turbine. So next, blade design. To produce an amount of power or wind turbine's blade generally needs to be large and tall. It is shaped to generate the maximum power from the wind at the minimum cost. Improvements in design has produced new wind turbines, which are more compact, quieter, and generate more power from less wind. Its lengths vary at around 50 meters, with 107 meter currently the longest from Siemens Gamesa. So itong blade design, ito yung malalaking blades. O ito yung mga design na kailangan na sakto para ma-produce ang maximum efficiency niya. At para makita kung improvements to produce which is more compact or quieter depende sa hangin or sa hangin. So, yung blade design, dito nakaka-base minsan yung conventional wind turbine or ano yung pwede i-produce o kayang gawin ng isang wind turbine. So, ito yung Siemens Gamesa, nakikita natin, longest in the world. Sobrang laki niya is 107 meter. So, next. Blade design. Airfoils is the cross-sectional shape of the blades that determine its aerodynamics. They are key to the blade design. This airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and efficiency. So, makikita natin din yung diagram. Ito yung airfoil. O tinatawag na cross-sectional shape of the blades. So, ito yung makikita natin na magpo-produce or sila yung key to the blade design. So, with torque, this allows the blade tips of a wind turbine to move faster than the wind is moving. So, sa salita na yun, ito yung nagpo-produce or nagbibigay way para nabilisin yung hangin. So, to generate more power and efficiency. So, next, natin dito yung thin airfoil family and thick airfoil family. Makikita natin yung pagkakaiba-iba niya. Isa malapad, isa may parang lumaki. At yun yung pagkakaiba-iba na pwede i-produce ng isang airfoil o isang sa blade design.
How windmills work. So from the previous slides, pinakita kung paano nga ba i-design ang isang blade ng windmill. So dito na pag-usapan natin paano nga ba gumagana ng windmill. Kasi kung tatanungin tayo kung paano ito gumagana, siyempre hindi naman dapat sabihin natin na dahil lang ito sa hangin o dahil lang sa lakas ng hangin kaya ito na gumagana. So hindi, maring meron ding sabihin natin na meron physics na nakatago dito sa windmill kung paano ito gumagana. So gagamit tayo ng ilang prinsipyo ng windmills ay ilang prinsipyo ng physics para masagot yung paano nga ba ito umiikot. Siyempre, ano natin, pamilya tayo sa windmill, di ba? Dito pa lamang sa Pilipinas, isa na rin sa malaking factor kung bakit merong mga kuryente sa North Luzon. So, hindi lamang sa pamamagitan ng hydropower plant, kundi sa pamamagitan din ng mga windmills. Yan, kilala yung Ilocos Norte para sa mga windmills, mga naglalaki ang windmills. So, dito, pag-usapan natin the aerodynamics behind the windmill. So, what is aerodynamics? Kung babalikan natin, kung ano nga ba ibig sabihin ng aerodynamics, sabi dito, the study of the properties of moving air and interaction between the air and solid bodies moving through it. So, ibig sabihin, kapag sinabing aero, means air. So, pag sinabing dynamics, ito yung mga bagay na kumikilos sa pamamagitan ng hangin. O sabihin natin na nagagawang gumalaw sa pamamagitan ng hangin. So, isang example na rin dyan, hindi lamang sa windmills, kundi yung mga sabihin natin mga pakpak na mga aeroplano. Yung mga naglalaki ang airplane. So, sa mga example din na mga bagay na merong sabihin may kakayahan na gamitin yung hangin bilang source ng power. So dito, ito nga yung pag-usapan natin how windmills works. So, sabi dito, wind turbines blades work by generating two aerodynamics forces, the lift and drag. This is due to the wind and their airfoils. So, paliwanag na po ng mga kasama ko kung ano ibig sabihin ng airfoils. Pero dito sabi niya, yung pag-ikot ng mga blades ng windmills ay ginagamitan ng dalawang force. At yung force na yun ay tinatawag na lift force and drag force. So ano po ibig sabihin ng lift force? Lift force is perpendicular to the airflow and is in line with blade rotation. So ibig sabihin, kapag sinabi perpendicular to the airflow ay nakahilig mismo sa may hangin. At kapag sinabi naman drag force is in line with apparent wind direction. Ibig sabihin, nasa kasalungat naman na part, which is in opposition to the blade rotation or blade motion. Drag increases in proportion to the frontal area of an object facing the wind. So, merong formula na ginagamit para dito sa lift force and drag force. So, makikita po natin yan sa next slide po natin. So, kapag sinabing CL, yan, ibig sabihin lamang po yan is coefficient of lift. So, yung makikita natin na formula, dito naman sa kabilang bahagi niya, yung nasa gilid na side, is wind density, yung una. And yung katabi po niya is the velocity of the wind. Yan yung makikita nyo, number to sa taas na bahagi po. And the next one is the area of blades. So, yan, over to lamang po natin. So, itong formula na to, ito ay para sa lift force. So, meron pang formula para naman sa drag force. Ito naman is, makikita natin, CD is equivalent yan sa coefficient of drag. So, halos pares lamang sila, pero kung titignan natin, yung dulong part is naging AR na. Pero yung AR na yan is, ibig sabihin lamang po yan is reference area. So, ganun din. Over to lamang natin yan. At yan. Hindi naman natin kailangan na mag-solve pa dito. Pero pinakita ko lang po sa inyo kung ano yung mga formula na pwedeng gamitin para sabihin natin na ito yung mga formula na ginamit kung paano mapagana o ilang pressure o ilang density ng hangin na kailangan para sa pag-ikot ng blade ng isang windmill. So, yan. Another thing that the airfoil is able to bring is for the blade to attain difference in pressure on both sides. The most curved side, or we say the convex side, generates low air pressure, while high pressure air pushes on the less curved side with slightly concave part, and this is actually the reason for blade rotation. So, meron tayong example dito. So, ito example naman po natin kung paano nga ba yung tamang pag-ikot o sabihin natin na how the blades of the windmill works. So, ito, nakita ko sa inyo. Para, kasi sa mga slides natin, mga picture lamang yun. Mas maganda kung magkakaroon tayo ng actual example. So, ganyan ang itsura niya. Kung papansin nyo, merong, yan. Kung papansin nyo, ito. Dito, meron dapat na slightly, kung ito, naka-curve lang siya, slight. Dito, kailangan talagang curve na curve siya. So, ganyan nakadesign yung mga blade. Siyempre, hindi lamang yung design na pwedeng gamitin sa pag-design ng blade ng windmills. Meron pang iba't ibang design. Pero siyempre, ito yung kinuha kong example para mas madali natin maintindihan. So, ito. Pero siyempre, kung example pa natin na mas maigi yan, kita na ito dito. Para mas makita nyo kung paano. Sabihin na natin na ito yung mismong muso ng windmill. So, ito isang blade lang. Kung mapapansin nyo, ganyan. Nandito yung parang buntot niya. Pero syempre, hindi lamang basta ganyan yan. Kailangan may twisted na part. At kailangan sabi nga kanina, dapat perpendicular sa airflow. Kaya, dapat yung pagkakadesign ng windmill, dapat meron talagang hindi siya ganyan, kundi mismo naka-lift mismo yung front niya at twisted na pagdating sa may tail. So, kung mapapansin nyo, ganito din yung naging prinsipyo ng mga nag-design sa mga wings ng airplane. So, paano nga ba gumagana? Kanina, pinaliwanag kung ano yung lift force and drag force. Pero, example natin yan, kapag tinatawag na lift force, ito yung nag-aangat. So, kapag bumangga yung hangin dyan, merong pressure na tumatama. At the same time, ito yung magiging attack ng wind para magkaroon ng pressure pataas. So, the drag force naman, pag tumama na yung hangin, siya na yung magbababa. At yun na yung magiging dahilan kung bakit umiikot yung windmills. O sabihin natin na yung mga blades ng windmill. So, nung mga bata tayo, di ba, ina naman sa atin na siguro nakagawa na ng laruan na gawa sa dahon na parang maliit siya na windmill. So, di ba, yung laruan na yun, hindi naman yun umiikot dahil lang sa tumatakbo tayo, kundi mismo doon sa may pressure ng hangin na bumabangga mula doon sa mga blades nun. So, hindi dahil tumatakbo tayo, kundi dahil sa mismong pressure. Kung mas mabilis tayo tumakbo, mas malakas yung pressure ng hangin. At yun, mas mabilis siyang iikot. Pero kung sabihin natin na doon yan sinabi, yung naging mga salita ko kanina, kung bakit umiikot ang isang windmill, meron tatlong bagay. Una yung size, pangalawa is yung number of blades, pangatlo is yung shape ng blades. So, kanina, pinaliwanag ko kung ano ba yung kinalaman ng mga blades. So, yung design ng blades. At yun, kung pag-uusapan naman natin yung number of blades, diba nung mga old days, kung paano na-design ang isang windmill, ay talagang pa-circle pa siya, diba? At talagang sobrang dami. Pero time after time, dahil na rin sa pag-aaral, at meron pang mga theory na talagang napatunayan na hindi ang bilis ng isang windmill para makapag-generate siya ng mas malaking source ng kuryente, kailangan ay mas konti yung blades niya. Kaya ganun na rin yung naging pagbabago mula sa technology natin na pabawas na pabawas yung nakikita natin na design ng mga blades ng windmill hanggang sa ngayon, nasa modern days na tayo na nakikita natin na tatlo na lang, di ba? Parang electric pan na lang yung design. Pero hindi dahil sa sabihin natin na dito lang wala yung kinalaman, kundi talagang napatunayan na talaga na kapag mas konti yung blade, mas mabilis yung pagdaan ng hangin sa mga blades niya, na yun yung magiging dahilan kung paano yun umikot. At siyempre kung mataas na lugar yung windmill at kailangan ng malakas na hangin, siyempre kapag binuo nila yung blades na yun, mas mahihirapan yung hangin na makadaan at mag-cause yun na pwede masira yung windmill. Lalo na din sa Pilipinas, bagyuhin, di ba? Kapag nagkaroon ng bagyo, sobrang lalakas ng hangin, pwedeng yung mga windmill masira kapag mas malaking area yung nasasakop niya na hangin na dumadaan. So, yun. Yun yung mga factor kung paano nga ba gumagana ang isang windmills.
Let's proceed to wind turbine number of blades. Here's now the question. Based on the previous slides, what number of blades is the best design in consideration of all the factors in construction and operation of wind turbine? So, answer is 3 or 3. 3 yung pinaka-best number of blade na ginagamit sa wind farm. And halos lahat na ng wind farm ay 3 na ang ginagamit. So, later on, i-discuss natin kung bakit mahalaga yung number of blades sa isang wind farm. We've already know that the rear of the blade is curved more than the front. This varied shape causes a pressure differential when the air moves across the blade, which is what causes the blade to move. So, yung curve sa blade, isa yun sa reason para umikot yung blade. For example na lang yung sa electric fan. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. This is what sets the rotation of the blades in motion. Engineers must consider speed and drag in designing the blades to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag is created, the blade could move too quickly, causing them to break the sound barrier. So in designing blade, the one should minimize is the drag force, and the one need to maximize is the lift force. So let's proceed to the rule of thumb. First is the fewer blades, the better, since there will be less drag and an increase in efficiency. So kapag kasi marami yung blade, it serves as an obstruction. And kapag maraming obstruction, mas lumalaki yung drag force. So mas konti yung blade, mas mababa yung drag. At yung drag force ang gusto natin pababain kapag nagde-design ng blade. Second, the number of the blade increases the torque and reduces the optimum rotation speed. So ano yung increasing the torque and reduces the optimum rotation speed? So, ganito lang. For example, yung motor. Yung bilang ng ngipin ng sprocket sa motor, kapag yon dinagdagan or tinaasan, babagal yung speed ng motor. Pero lalakas siya. Lalakas na humatak. Parang kapag nilagyan mo ng sidecar or kahit ilan yung sumakay or mangkas sa'yo, kaya pero yung speed niya mabagal. So, maganda yung performance pero yung speed babagal. Just like the number ng blade. So, the more the blade, mas babagal yung ikot. And last, having fewer blades reduces drag. So, same lang ito sa rule number 1. Mas konting blade, mas mababa yung drag force. And kapag mababa yung drag force, ibig sabihin effective yung blade. Dahil sa pagde-design ng blade, need mababa ang drag force. So, now let's explain why 3 blade is the best among the other number of blades. Under the same circumstances, sa tingin nyo, which one rotates faster? Yung 1 blade or yung 3 blade? So, sagot is 1 blade. So, kanina na-explain natin na the fewer the blade, the lesser the drag. Kapag maliit yung drag, mas mabilis yung rotation. And when speed of rotation increases, the torque will decrease. So, dito muna tayo sa 1 blade. Because of the decrease of drag, 1 blade would be the optimum number when it comes to energy yield. However, 1 blade could cause the turbine to become unbalanced. And this is not a practical choice for the stability of the turbine. And kapag maraming unbalance, it causes too much stress in every individual parts, which will cause it to burn out easily. So, hindi talaga magandang choice ang one blade because of its stability issue. So, next naman tayo sa two blade. At first glance, two-bladed turbines seems like the optimal configuration for a wind turbine. So, perfectly balanced, and with one blade less than a three-bladed turbine, they will generate less drag. So, why aren't all turbines made with two blades? So, hindi na unbalanced kasi two blade na siya, balance na siya. So, pwede na, di ba? Pero, may issue pa rin about this. It has trouble in yawing. So, yaw is when its head for nacelle turns to face the wind due to an effect called gyroscopic precession. When a two-blade turbine yaw, it creates a wobble as the blades go from the vertical plane to horizontal plane, which places additional stresses on the mounting bearings, wearing them down faster. Hindi kasi naka-fix yung nacelle ng wind turbine. The whole wind turbine itself should follow the wind direction. Dapat nakaharap siya sa direction ng hangin. So, susundan niya yung direction ng hangin. Then, iikot yung nacelle. Yung pag-ikot ng nacelle, ang tawag doon is yung yawing. And when the two blades yaw, it becomes wobbly. Dahil dito magkakaroon ulit ng unbalanced force, which puts stresses on individual parts. And because of this, masasabi natin na hindi pa rin effective yung two blades when it comes to the number of design ng blades. So, hindi pa rin ayos ang two blades, and the best choice talaga is yung three blade. More than three blade. Any number of blade greater than 3 would create greater wind resistance, slowing the generation of electricity and thus becoming less efficient than a three-blade turbine. The more the blades you add, the more increasing of drag force, and it bring down its efficiency. Mas best talaga yung three-blade. So ngayon, define na natin yung three-blade. For these reasons, turbines designed with three blades are the ideal compromise between high energy yield and greater stability and durability of itself. So dito, balance na and wala na issue about stability. So this is the best number of blade when it comes to blade designing.
So next po tayo dito sa wind turbine parts and functions. So here we comes about blade tilting mechanism. So sabi po dito, according to the wind speed, the relative velocity angle of the wind also changes. A blade tilting mechanism is a sensor coupled parts of the wind turbine which tilts the blades and guarantees a proper alignment of the blades with the relative velocity so that its position is always the optimum angle of attack. So sabi po dito, yung blade tilting mechanism is nakabase po siya sa wind speed, at sabi po dito, ability daw ito ng turbine na mag-change ng kanilang angle of attack with respect of incoming wind. Sabi ko dito, this feature is crucial for optimizing the performance of the wind turbine under different wind conditions. So there are two main types of blade tilting mechanisms. So ano po kaya yung two types na yan? So here we come, number one, the fixed pitch blades po. So ano po ba yung fixed pitch blades? In this design, the blades are fixed at a certain angle and cannot change their pitch. The angle of attack is set during the manufacturing process and remains constant, while this design is simpler and less expensive. It has limitations in terms of adaptability to varying wind speeds. Sabi ko dito, fixed pitch blades are often used in small scale or older wind turbine designs. So, hindi na po siya kalimitang ginagamit ngayon, pero type po siya ng blade tilting mechanism. Number 2 po natin is yung tinatawag nating variable pitch blades po. So, ano po ba yung variable pitch blades? Kung number 1 po natin is yung tinatawag na fixed pitch blades. Number 2 po, variable pitch blades, which are more sophisticated and can adjust their pitch angle to optimize energy capture under different wind conditions. The pitch angle is the angle between the chord line, an imaginary line from the leading edge to the trailing edge of the blade and the plane of rotation. By changing this angle, the blades can control the amount of lift and drag they generate. So ito po yung kalimitang ginagamit ngayon, at meron daw po itong two types. Under the variable pitch blades, there are two types of it, which is number 1, natin is yung pitch control system. So ano po ba yung tinatawag nating pitch control system? In this system, each blade can be individually adjusted in real time to maintain optimal performance. Pitch control is typically achieved using hydraulic or electric mechanisms that change the angle of the blades. This allows the turbine to operate efficiently over a wide range of wind speeds and helps protect the turbine from extreme wind conditions by feathering at the blades, turning them parallel to the wind during high winds. At ano po yung number 2, yun po yung pitch control system. Saan po dito, nakokontrol po yung pitch at pwede pong i-adjust in real time para po ma-maintain yung main or maintain optimal performance. Number 2 po, blade feathering. Feathering refers to the adjustment of the blade angle to reduce the surface area exposed to the wind, effectively slowing down the turbine and preventing damage during high winds. Feathering is a safety feature that helps protect the turbine and ensures stable operation. So, yun po yung tinatawag natin blade feathering po. So, ina-adjust daw po yung blade angle para po ma-reduce daw po yung surface area exposed to the wind. So, na-adjust po siya at effectively slowing down the turbine and preventing damage during high winds. So, yan po yung dalawang parts ng variable pitch blades at under po yan ng blade tilting mechanism. At sabi po dito, the ability to adjust the blade pitch allows wind turbines to operate efficiently across a range of wind speeds, maximizing energy capture and ensuring safe operation in varying weather conditions. So, next slide po natin is yung tinatawag na nacelle. So, ano po ba yung nacelle? Sabi po dito, nacelle, the housing at the back of the blade, which contains the slow speed shaft, gearbox, generator, and other small parts inside it. So, yan po yung definition ng nacelle, pero ipaliwanag po natin ano po ba yung nacelle or ano po ba yung function ng nacelle na tinatawag natin. So, sabi po dito, the nacelle is a crucial component of a wind turbine. It is typically mounted atop the tower. So, halimbawa po ito yung tower natin. Andun daw po siya mismo sa pinagkakampitan ng tower. Sabi po dito, kung makikita natin sa ating PowerPoint, ito po yung ating tinatawag na nacelle. Kung saan dyan po nag-ooperate lahat or sabihin natin, may papaliwanag po natin mamaya kung ano yung nangyayari sa nacelle. Sabi po dito, it houses several key elements of the turbine's functioning, including the generator, sabi po dito, gearbox, and other controlling and monitoring system. The nacelle is positioned behind the rotor hub, where the turbine blades are attached. So, behind po siya ng turbine blades po. At sabi po dito, here are some of the main components typically found inside the nacelle. Number 1 po natin, generator. Ano po ba ang generator? Sabi po dito, generator converts the mechanical energy generated by the spinning rotor into electrical energy. Most modern wind turbines use synchronous generators or asynchronous generators. So, yan po yung number 1 part po. Yung number 2, gearbox. If the turbine has a gearbox, it is used to increase the rotational speed of the rotor, optimizing it for the generator. Some newer designs, especially in direct drive turbines, omit the gearbox. Number 3 po natin, yaw system. What is yaw system? Yaw system enables the nacelle to turn horizontally. Yaw to face into the wind. This helps the turbine capture the maximum amount of wind energy. The yaw system includes a yaw motor and various sensor for wind direction. Ano pa po? Number 4 natin, control system. Electronic control systems monitor and control various aspects of the turbine's operation, including blade pitch, yaw direction, and generator output. These systems optimize the turbine's performance and ensure safe operation. Number 5 po natin, braking system. Wind turbines are equipped with braking systems to control the right rotation of the blades in strong winds or during maintenance. The brakes can be applied to the rotor or the generator to stop the rotation. At number 6 po natin, cooling system. Components within the nacelle, such as the generator and power electronics, generate heat during operation. Cooling systems help dissipate this heat to prevent overheating and ensure the turbine's efficient operation. So, yan po yung parts ng nacelle natin. Number 1 natin is yung tinatawag nating generator, gearbox, yaw system, control system, braking system, and cooling system. The nacelle is an essential part of the wind turbine structure, providing protection to the internal components from environmental conditions such as wind, rain, and temperature variations. It also facilitates maintenance activities, as technicians can access the components housed within the nacelle. Next po natin, ano po ba yung parts ng nacelle na kung saan tinatawag nating gearbox. Pag-usapan natin kanina kung ano po yung gearbox. At sabi po dito, gearbox, the component, sabi po sa slide natin, the component which converts the slow rotation of the blade into faster speed. This is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve a grid quality voltage output. Most generators need to be turned to 1,500 revolution per minute, or tinatawag po natin 450 Hz po, and 1,800 revolution per minute, or 60 Hz po. In no way it is feasible for a turbine blade to move that fast. So, paliwanag po natin ano po ba yung gearbox talaga. Sabi po dito, a gearbox is a mechanical component that plays a crucial role in the turbine's power generation process. The gearbox is responsible for adjusting the rotational speed of the turbine's rotor to a speed suitable for the generator. Its primary function is to convert the relatively slow rotation of the turbine blades into a higher speed rotation required by the generator to produce electricity efficiently. So kung makikita natin, di ba po sa mga wind turbine, di ba po kung titignan natin, napakabagal lang ng ikot ng turbine. Pero doon pala sa gearbox po na tinatawag, siya po yung nagpapabilis. Sabi po doon, siya daw po yung responsible for adjusting the rotational speed. So ibig sabihin na kailangan po ito ng 1,500 revolution per minute. So ganun po yung nangyayaring process sa gearbox. At sabi po dito, ito po yung here's how the gearbox operates within the wind turbine. Paano po ba nag-operates? Number 1 natin sa rotor rotation. Ano po ba yung tinatawag nating rotor rotation? Sabi po dito, wind causes the turbine blades to rotate. The rotor, which consists of the spinning blades and the hub to which they are attached, experience relatively slow rotational speed. Sabi ko nga po kanina, ito po yung napakabagal na ikot lamang kung titignan natin. At sabi po dito, ito po yung number 2 natin, low speed shaft. The rotor is connected to a low speed shaft which rotates as the speed driven by the wind. Sabi ko nga po, napakabagal natin. Sabi ko po, kung titignan natin, parang mabibilang lang natin yung ikot pag nahanginan na po. Pero dito na po papasok yung number 3 natin, gearbox na tinatawag. Sabi po dito, the low speed shaft is connected to the gearbox. So una sa rotor rotation, sumunod sa low speed shaft, then papasok po tayo sa gearbox. At ito pong gearbox, within the gearbox, a set of gears, including both gears with different numbers of teeth, adjust the rotational speed. The gears increase the speed of rotation, preparing it for the generator. So ito po yung sobrang dami daw po na gear na kung saan kapag umikot na po yung turbine natin, iniikot na rin po ito na sobrang bilis. At dito na po papasok yung high speed shaft po. Ano po yun? The high speed shaft is connected to the other side of the gearbox. The shaft now rotates at a higher speed than the low speed shaft. At sabi nito, ito na po yung process na kung saan higher speed na po siya kumpara sa low speed shaft po. At number 5 natin yung generator. The high speed shaft is linked to the generator which converts the mechanical energy from the rotating shaft into electrical energy. So sabi po dito, the gearbox allows for an optimal match between the relatively slow rotational speeds at which wind turbines operate and the higher speeds needed for efficient power generation. However, it's worth noting that some modern wind turbines designs, particularly direct drive turbines, eliminate the need for a gearbox. Direct drive turbines connect the low speed shaft directly to the generator, avoiding the complexity and potential maintenance issues associated with the gearbox po. So yun po yung process ng ating gearbox. And then sabi po dito, gearbox, a common ratio is about 90 to 1. With a rate 16.7 revolution per minute input from the rotor to 1,500 revolution per minute output generator. So ito po yung process ng tinatawag nating gearbox po. At dadako po tayo dito sa tinatawag nating direct drive. Ano po ba yung direct drive na nabanggit natin kanina dito? Sabi po dito, direct drive, at makita natin sa slide, ito po siya, gearless na po siya. At sabi po dito, in a direct drive turbine, there is no gearbox. So sabi doon, wala na pong gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades po. So comparing to gear type, the slow rotation and decrease in moving parts of PMDD generator reduces fatigue and stresses on the turbine, resulting to reduce noise and vibration, longer lifetime, and lower cost of maintenance. So yan po yung tinatawag nating direct drive. At sabi po dito, isa na po siyang gearless wind turbine technology na kung saan ito na po yung nauuso. Eliminates the needs the need for a gearbox between the rotor and the generator. At sabi po dito, the low-speed shaft connected to the rotor is directly linked to the generator's rotor which operates at higher speed. This approach has become increasingly popular in modern wind turbine designs for several reasons. So bakit po ba siya ginamit? Number one po natin, simplicity and reduced maintenance. Nabanggit po dyan kanina, gearboxes are complex components that can be prone to wear and require regular maintenance. By eliminating the gearbox, direct drive turbines reduce the number of moving parts and potential points of failure, leading to lower maintenance requirements and increased reliability. Number two reasons po, efficiency. Direct drive turbines can achieve higher efficiency compared to gear turbines. The absence of gearbox eliminates mechanical losses associated with gear systems, resulting in more direct power transmission from the rotor to the generator. Number 3 po natin, nabanggit kanina, reduce noise. Gearboxes can generate noise during operation, contributing to the overall noise produced by a wind turbine. Direct drive turbines with fewer moving parts and no gearbox tend to be quieter during operation. Number 4 reason po is compact design. Gearless turbines often have a more compact and lightweight design compared to geared turbines. This can make transportation, installation, and maintenance easier and more cost-effective. Number 5, improved durability. The simplicity of direct drive systems can contribute to improved durability. With fewer components and potential points of failure, direct drive turbines may have a longer operational lifespan. Number 6, variable speed operation. Direct drive turbines often operate at variable speeds, adjusting the rotor speed to optimize energy capture under different wind conditions. This flexibility allows for better performance in varying wind speeds and enhances overall energy efficiency. So yan po yun. Tinatawag natin direct drive. Yan po yung several reasons po niya kung bakit mas ginagamit na siya ngayon sa panahon natin. Sabi po dito, while direct drive technology has several advantages, it also has some challenges. The direct drive generator is typically larger and heavier than the generator used in geared turbines, which can impact the overall weight and transportation logistics of the wind turbine components. Additionally, direct drive turbines may have higher upfront costs due to larger generator size. Overall, the choice between direct drive and geared technology depends on factors such as project size, site conditions, and economic considerations. Both technologies continue to be used in development of modern wind turbines. Sabi po dito, direct drive, an important fact is that due to wind inconsistency, the type turbines often operate at partial loads po. The efficiency of the PMDD generator extends even in these conditions because it continues working nearly to nominal values. This design makes suited even in offshore wind applications. Next po natin, sabi niya, on main disadvantage of PMDD is that to make up for its low rotation, more magnets are added to create the required frequency and power. This increases the diameter of the generator, which makes it larger and often heavier than gear type wind turbine. Nabanggit ko po kanina, ito po yung disadvantage niya at mga challenges po niya na kung saan larger po siya at mas mabigat. Bakit po? Kasi kailangan daw po siya ng maraming magnet na kung saan nag-record po siya ng frequency and power. Sabi po dito, this increases and increases diameter. So, ibig sabihin, malaki daw po talaga yung makakain nito o masasakop nito. Another thing is that the additional magnets being used in this type is made up of neodymium, which is expensive. So, sobrang mahal daw po nito magnet na ginagamit dito sa direct drive. Gearless po natin. At sabi po dito, the cost and weight of direct drive turbines have prevented it from presenting major competition to the gearbox turbines until recently. But other experts claim that direct drive technology will eventually become the dominant one, since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDD generators have more possibilities for improvement. So marami pong nagsasabi, mga expert, na mas prefer nila itong direct drive na tinatawag. Bakit po? Kasi sabi nila, yung gearbox na nakasanayan doon is nasa limit na po ito or nasa efficiency point na po siya na kung saan nahihirapan na po silang isipan kung paano ma-improve. Ngunit ito pong ating direct drive technology is marami po siyang possibilities para ma-improve po natin. Next po natin, brake. Sabi po dito, the brake system in a wind turbine is a protective device coupled with sensors which automatically rotation of stops the blades whenever it detects activities that could harm the system during operation. Very high wind speeds, vital parts not working, maintenance power lines, and etc. So, from the word brake, so ito po yung nagpapahinto o siya yung nagsisilbing protection ng isang wind turbine para po makita kung anong problema sa isang wind turbine na tinatawag. So, ito pong brake na tinatawag is designed to stop or slow down the rotation of a turbine's rotor in specific situations. This is essential po ito for safety features, protect the turbine from damage during extreme wind conditions or when maintenance and repair work are required. So, meron daw pong two types ng brake in the wind turbine. Number 1, rotor brake. Number 2 natin, generator brake. Ano po yung rotor brake? Rotor brake is applied directly to the turbine blades or rotor to stop them from turning. This brake is engaged during maintenance activities or in response to certain wind conditions to prevent the turbine from spinning too fast and cause damage. The rotor brake can be hydraulic, mechanical, or electric depending on the turbine design. Number 2, generator brake. The generator brake, also known as the mechanical or electrical brake, is applied to the high-speed shaft connected to the generator. It stops the rotation of the generator rotor, preventing it from producing electrical power. Similar to the rotor brake, the generator brake is used during maintenance and for safety in high wind conditions. So, yan po yung brake natin tinatawag. Next po natin, yaw system. Ang sabi po dito, yaw system is a sensor-equipped mechanisms consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nacelle on top of the tower so that the sets of blades is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy. So ito pong yaw system is siya yung tinatawag natin, siya yung papaikot sa wind turbine para maharap o masalubong nito yung hangin. So sabi ko dito, it has two types po. Number 1 natin is yung tinatawag natin yaw motor. Yaw motor, number 2, yaw drive, and number 3, yaw bearings. At makikita natin sa picture, ang yaw drive is siya yung malaking gear na kung saan siya yung nagpapaikot. At yung yaw motor siya yung nagsisilbing, sabi ko dito, actuator responsible for physical rotating the nacelle. At sabi po dito, yung yaw bearings are large bearings that supports the nacelle and allow it to rotate smoothly. So yan po yung process ng yaw system natin. At pang-last natin is yung tinatawag nating tower. Sabi po dito, wind velocity increases at a higher altitude. This means the taller the tower, the greater electricity it can produce. Majority of the wind turbines are supported by conical tubular steel towers with a height of usually 75,110 meter, or it consists of 250 to 370 feet, depending on the blade's diameter. The tallest is still for completion in the mid of 2022, which is 280 meter to be installed at a test center in Western Jutland, Denmark. So, ito lang po yung pinakamataas ngayon sa panahon natin at kasalukuyang ginagawa year 2022 na ang taas po niya is 280 meter at nakalagay po siya or makikita po ito sa Western Jutland, Denmark po. So, ano po ba yung tower natin tinatawag? Sabi po dito, meron po itong key features and functions na kung saan makikita natin sa tower. Number 1, yung height dito. Ano po ba yung height? Ang height po nagsilbing tawag po dito na banggit kanina, the higher the altitude. Sabi po dito, the faster it rotates po. Sabi po dito, the height is a critical factor in capturing higher wind speeds as wind generally increases with altitude. Taller tower enables the turbine to access stronger and more consistent winds, enhancing overall energy production. Number 2 natin, construction material. Commonly constructed po ito sa mga bakal, concrete, o sabi nga po dito sa tubular na tinatawag, conical tubular po. Number 3, foundation. Ang foundation po nito, the tower is anchored to the ground through a foundation that provides stability and support. The type of foundation can vary depending on factors such as soil conditions, wind turbine size, and project location. Number 4, lattice or tubular towers. Nabanggit ko na po, yan na po yung tinatawag natin construction material po niya. Number 5, installation and transportation. Tower sections and typically transported to the site in manageable segments and assembled on site. So ina-assemble na po itong tower na to. At number 6, accessibility. Towers are designed to provide access to the for maintenance and repair activities. Pag sinabing accessibility, so pwede po siyang ma-access, maakyat, maayos, magkaroon ng maintenance po. At sabi po dito, the tower is critical component in the wind turbine system, playing a key role in harnessing wind energy efficiently and safely. The choice of tower height and design depends on factors such as wind conditions, turbine size, and the specific requirements of the wind energy project. So yan po yung tinatawag nating wind turbine parts and functions.
Let's proceed to wind turbine tower and blade diameter ratio. It is now the ratio of nowadays blade design regarding the height of the tower and the diameter of the rotor. So dati, mas malaki yung average hub height sa average rotor diameter. But nowadays, because of engineering design is improving, so nabaliktad na. Mas malaki na yung rotor diameter sa hub height. So next, saan ba magandang itayo ang mga wind turbines or wind farm? So the best places for wind farms are in coastal areas, at the tops of rounded hills, open plains, and gaps in mountains. Places where the wind is strong and reliable. So some are offshore or onshore. To be worthwhile, there should be an average wind of around 25 km per hour. So let's proceed sa advantage and disadvantage. So first, wind is free. Wind farms need no fuel. It produces no waste or greenhouse gases. The land beneath can usually still be used for farming. And last, a good method of supplying energy to remote areas. And its disadvantage is first, the wind is unpredictable. It changes speed throughout the day and from season to season. Suitable areas for wind farms are often near the coastal area, where land is expensive. It also can affect television reception on nearby places. And here are the top 6 largest wind farm. So first, Gansu Wind Farm of China, Alta Wind Energy Center in California, USA, Mupandal Wind Farm in India, Hornsea Project 1 sa UK, next is Mark Bigden Wind Farm in Sweden, and last, Jaisalmer Wind Farm sa India. So here are some details regarding Gansu Wind Farm ng China. So noong 2010, mayroon ng 3,500 turbines with an installed capacity approximately 5,160 megawatts. So compare sa Burgos Wind Farm sa Ilocos Norte, Philippines, mayroon lamang 150 megawatts. At mayroon lamang na 50 wind turbines with a capacity of 3 megawatts. So summary of wind operation. Ihipan ng hangin yung blade, then iikot yung gearbox and generator, and yung generator is connected sa transformer. Yung purpose ng transformer is to step up the input voltage coming from the generator. Then connect na yon sa substation papunta sa mga bahay-bahay. So that's all guys, thanks for listening.